Hello everyone, welcome back to the course Introduction to Infrastructure Asset Management. This course is offered under MOOCs, an initiative of Government of India. In this particular week, we had started our discussion around economic decision making. We saw the need to consider a life cycle perspective. We talked about both LCCA and LCA. Then in the last two lectures, we talked about multi-criteria decision making, where we discussed about AHP, which is Analytical Hierarchy Process. Now in this week, we will talk about optimization. Basically within decision making, our focus has been on understanding how to do budget programming. What are the different methods to select appropriate projects? We have seen there are several methods like using subjective experience, decision metrics, decision tree, AHP and optimization. Here the focus has been on understanding how to do performance based decision making. We are trying to choose a project based on its current performance or its current condition. There are different triggers which are helping us in selecting an appropriate project for maintenance and rehabilitation. We also discussed that if there are multiple criteria, then we can use AHP to choose the right type of project and the right type of treatment method. However, in all these methods, the focus has been on the performance criteria. We have not kept in mind the budget which is available and the time consideration. Budget basically means how much budget is available. Based on that, what are some of the appropriate projects which can be done? We have not talked about that. Moreover, we have not discussed the time consideration, which is when should we maintain or rehabilitate a project? What is the right time to do maintenance? Right time is not just a function of current performance, but it is also a function of how many projects we have and what is the current condition of all those projects. So the methods which we have discussed till now were focused on performance based decision making, but they were not keeping account of how much budget is available and what is the right time to do a maintenance. This is where optimization comes handy. This is the fourth and the last lecture within this week where we are discussing the decision framework for infrastructure asset management. Here we will discuss decision making using multi-objective optimization. My name is Chirag Kothari and I am a faculty member in the Department of Civil Engineering at IIT Kanpur. In one of the previous lectures, we briefly discussed about optimization. We saw that it's a method which is used for budget programming. I had briefly introduced the definition of optimization. We had discussed that within optimization, the objective function can be either a maximization function or a minimization function. We had briefly talked about the fact that there are several considerations which can be incorporated in an optimization model. Then I had talked about the fact that an optimization method can involve single or multiple objectives, it can involve single or multiple constraints, it can be for a single year or for a multi-year, and it should be comprehensive for infrastructure asset management decision making, where it should help us in answering which project is important, when is it important, and what type of maintenance or rehabilitation should be done on that particular project. In this lecture, we will focus on multi-objective optimization, a multi-criteria decision making approach. Before we get into the discussion, let's briefly talk about what is optimization. Optimization basically means we try to find an optimal solution. An optimal solution means the best solution, which means that whenever we try to optimize something, we are trying to make it best under the circumstances. Within the infrastructure asset management domain, it basically involves some mathematical or analytical tools to identify an optimal set, which is the most likely best set of projects which can help us in maximizing value while adhering to constraints. Here, an optimization function can include both maximization or minimization type of problems. Any optimization problem involves few standard terms. Let us discuss the optimization vocabulary which will help us in understanding them. An optimization problem consists of an objective function which is given as f of x. Either we try to maximize f of x or minimize f of x. Next, any optimization problem will include variables. We have seen that f is a function of x, where x are all the variables which we can control or vary. The idea is we want to either maximize f of x or minimize f of x. What we are allowed to vary is x. Now, x can actually be x1, x2, x3 and so on. These are the variables which we can vary. In case of infrastructure decision making, what we can vary is which projects will get treatment and what type of treatment. Also, when will they get a treatment? All these are variables in our case. Next, any optimization problem also includes constraints. Constraints are there to put a limit on how much a given variable can vary, what is the lower limit and upper limit of a variable. These constraints can be both equality constraints or inequality constraints. Moreover, we can have a case where an optimization problem is unconstrained, that is, there is no constraint at all. However, in real world it is rare because decision makers, when trying to plan asset maintenance, have to keep in mind several constraints which govern the overall decision making. Optimization is a well researched and documented area. There are several courses which are available which discusses different types of optimization. The goal in this lecture is to introduce the fact that optimization can be used in infrastructure decision making. In this course, we will not get into the discussion on different types of optimization technique, the challenges and benefits of using one over another. Here, I will just briefly discuss about them, but I will not get into any mathematical discussion. At the end of this lecture, there will be a set of references which will be available, which the students can look into to read more about optimization. Let us briefly discuss different types of optimization problems. We can have a constrained optimization problem, that is, there are constraints, or there can be unconstrained optimization problems. Similarly, we can have a problem which has a single variable, that is just f of x, or we can have a problem which has multiple variables x1, x2, x3 and so on. So, we can have an optimization problem which involves multivariable problems. Moreover, we can have a case where we have discrete variables, or we can have a case where there are continuous variables. When we say discrete variables, the idea is that these variables are not on a continuous scale. For example, if we say that variables can only take integer values, then it is a discrete variable where x can only take integer values. On the other hand, if we say x is continuous, then it can take any value between 1 and 4, which can include 1.1, 1.01, 1.001 and so on. So, an optimization problem can involve both discrete variables or continuous variables. Moreover, an optimization problem can have both linear and non-linear equations. Till now, we have been saying that an optimization function z is equals to f of x. Now, the function can either be linear or non-linear. Similarly, the equations around constraints can also either be linear or non-linear. Moreover, the optimization problem can be deterministic, that is, there are no uncertainties. On the other hand, it can be stochastic or probabilistic. That is, if the constraints, variables have some uncertainty or variability, then we can use a stochastic based optimization method. So, it is important to note that we can have different types of optimization problems. The choice of an optimization technique depends on what type of problem we are trying to solve. Does it involve multiple variables? Does it involve linear or non-linear equations? Are the variables discrete or continuous? Is there an uncertainty in the variable? And so on. All these factors help us in deciding an appropriate optimization technique. There are several types of optimization methods which are available. Let us briefly talk about them. There are some traditional calculus based methods which involve calculus to determine an appropriate optimal solution. Then there are linear and non-linear programming based methods. Moreover, we have integer programming methods. Integer programming methods are used in case of discrete variables. That is, if our variables are discrete and they can only take integer values, then we can use integer programming. Moreover, there can be a case where we have to use mixed integer. Mixed integer is used when some variables are discrete and others are continuous. In addition to these methods, there are numerical optimization based methods like the Newton method, the simplex method, and so on. Moreover, there are some evolution based optimization methods. These methods are derived from nature. They try to mimic the nature and use that phenomenon to find an optimal solution. These includes methods such as genetic algorithms, swamp based methods like ant colony, and so on. Lastly, there are both heuristic and non-heuristic algorithms. Heuristic algorithms basically are a method where we use educated guess to find a near optimal solution. This is suitable when we have a fairly complex problem where it is difficult to find a solution in the entire solution space. In such cases, we just rely on a heuristic method which starts with a more educated guess and then tries to refine its solution to find a near optimal solution. It may or may not be the best solution, but there are situations where computational limitations do not allow us to use other techniques and we have to rely on heuristic based methods. So, this is just a broad introduction of the different optimization methods which are available. After a brief discussion on optimization and different types of optimization methods, now let us see how optimization can be used for infrastructure asset management decision making. Can be understood with the help of an example. Let us say there is a road network in a city. This road network has 400 kilometers of roads. Now, to do or maintain these roads, we have to use a method for efficiency and better control. The decision makers generally divide the entire stretch of road into different sections purely for recording purpose. So, here let us say we have 400 pavement sections, each section is of 1 kilometer each. Now, the road condition for each section is recorded. We have the condition score for each of these pavements. We are using pavement condition index here. If the condition score is given as 0, it means the condition is extremely poor. On the other hand, if the condition score is 100, then we can say that we have excellent pavement conditions. Generally, the pavement condition index is a combination of lot of factors. but the way we define it, generally payment condition index is a combination of several factors, but it is summarized in the form of a numerical number on the scale of either 0 to 100 or 0 to 10. Say now it is expected that the payment will deteriorate with time, and the deterioration will be around 3% every year. So, if there is a pavement section which has a condition of 100 in a given year, then in the n plus 1 year, the condition will reduce by 3%. So, it will come down to 97. Now, say we are given a task to develop a maintenance plan for this particular road network, and we need to do that for the next 10 years. Let us see how we can utilize optimization to solve this problem, to develop a maintenance schedule for maintaining 400 kilometers of roads. We have already seen that any optimization problem will include an objective function, some variables and some constraints. In our case, let us discuss what will be the objective function. The objective function can be as simple as we want to maximize the average network condition score. So, we say that the optimization function is a maximization function where we are trying to maximize the overall average network condition. Here Z is the optimization function, PCI is the payment condition index or condition score. If you see the initials here, I and T, it represents the payment condition score for section I at time T. Moreover, N is the total number of sections, which in our case will be 400, and T is the total time duration, which is 10. So, basically what we are doing is we are trying to find the average network condition score using this function, and we want to maximize it. This is just one example of an objective function. There can be other objective functions such as minimize agency cost, minimize accidents, minimize user costs, reduce environmental impacts, and so on. For now, let us keep the problem simple and assume that we have a single objective function where we are trying to maximize the average network condition. Now, let us discuss what are the variables. We have seen that x1, x2, x3, so on are variables which we can control. In other words, these are the potential options which we have for our decision making. In asset management, we have the following options. First is we can choose which payment section should receive maintenance. Since we know that there are only 400 payment sections, one of the variables is allowed to vary from 1 to 400. Next, we should decide when can it receive a maintenance. The answer will lie on either it can receive a maintenance in the first year, second year, or in the 10th year. So, the variable can vary from 1 to 10. Lastly, what should be the type of maintenance we carry out? Let us assume that there are only 5 options. So, this particular variable can vary from 1 to 5. So, I hope this idea is clear that when we want to maximize the overall average network condition, we have few things in our control. In other words, the optimization problem will try to give an answer to which payment section should receive a maintenance, when should it receive it, and what should be the maintenance type. Optimization problem will try to look into all the feasible solutions to find the optimal solution. Now, let us dive deeper into what are some maintenance types. Here, let us assume that there are only 5 treatment options. Each of these options have an associated cost and it will have an associated benefit. So, in our case, let us assume that for all these 400 sections, we have 5 options. Either we can do nothing. If we do nothing, the cost per lane kilometer will be 0. Obviously, if we are not doing anything, the expected improvement will again be 0. Next, we can do a preventive maintenance. Say the cost is around 2,50,000 rupees per kilometer. Now, we can say that when we try to do a preventive maintenance, the condition score will improve by a factor of 3. So, if the condition of a payment is 70, after preventive maintenance, it will go on and become 73. These are more of educated assumptions. Next, we have an option of doing a light rehabilitation, which say will cost around 10 lakhs and the condition is expected to improve by a factor of 10 and so on. So, again this information is important for the optimization model to understand that if I choose a particular maintenance type, what will be the cost incurred and what will be the expected benefit. Now, in addition to the objective function and the variables, another important consideration is the constraints. Let us see what can be some of the potential constraints in the decision making. Constraints can include the following. First, you want the optimization model to put limits on some of the variables. For example, you can say that payment condition, no matter what, should not go above 100. That is, when you are doing a decision making, it should restrict the payment condition to be maximum 100 because the scale is not defined above 100. Similarly, the scale is not defined below 0. So, what we are saying is, say there is a road section which has a condition score of 90 and now I try to do some kind of light rehabilitation on it, which is say expected to improve the performance by 15. This actually will take the payment condition to 105, but we know that payment condition over 100 is not defined. So, we put a constraint on the variable that no matter what, the condition cannot go above 100. Similarly, for treatment options, we have said that there is a restriction on the treatment options variable. It can either have a value of 1, 2, 3, 4 or 5. It cannot have any other value. Next, we can have considerations around the annual money which is consumed should be less than the annual budget which is available. This is the most important constraint. What we are saying is that the total projects which are planned in a given year, the total cost of that project should not be above the budget which is available. Oftentimes, in decision making, we also have a restriction that at least some percentage, say 70 or 80, some percentage of the budget should be consumed. Here, different state agencies or highway agencies have a requirement that if they are allocated a certain amount of budget, they must utilize that in a given year. So, this again becomes another constraint. What we are saying is that the summation of all the projects, the total cost should not go above the annual budget, but it should not be below 80% of the available budget. Moreover, we can have another practical constraint which is on the lines of you want to limit the number of times an MNR treatment can be applied. Say in this case, we only want 2 maintenance and rehabilitation treatments should be allowed every 5 years. The idea here is that we do not want a condition where a given section of road is always under maintenance. We want to restrict that. So, we can define this as a constraint that in every 5 years, there can only be 2 maintenance and rehabilitation treatments possible on a given section. So, say I have a section 1, now year 1, year 2, so on till year 5. I can say that, say first year I do nothing, treatment option 1. Second year I do a preventive maintenance. Third year again I do nothing, Fourth year, say again the model says we should do preventive maintenance. Now what we are trying to say is that this model will not be allowed to have more than 2 treatment options every 5 years. Accordingly, in the 5th year, we should do nothing. This is a very practical constraint because you do not want a given road section to be under maintenance always. Now, finally, we can have another consideration which could be around safety, where you are saying that the PCI or the payment condition should not fall below the critical limit. In this course, we have always been discussing about this particular curve where we say performance goes down with time and we do not want it to fall below the critical limit. So, this can be another consideration which can be decided, where the decision makers might say that no matter what, payment condition index should not go below a given number. It should always be greater than or equals to say 40. So, these are some of the potential constraints which can be utilized to make the optimization problem more suitable for real world. Based on the optimization problem and its characteristics, let us discuss what could be a good optimization technique which can be used for infrastructure decision making. So, choosing an appropriate optimization technique, as we have discussed, will be a function of what type of optimization problem we have, what type of objective function we have, what type of constraints we have, and so on. Let us discuss. First, we have seen that the problem, the way we are defining it, it can actually include both linear and non-linear functions. This is an important aspect because it will govern what type of optimization methods we can use. Moreover, we saw that in our case we have discrete variables. For example, we said that treatment option can only be 1, 2, 3, 4 or 5. We say that a treatment option known as 1.2 or 1.3 is not defined. So, we have restricted the solution space to discrete variables. Similarly, the choice of payment section is again a discrete variable. It can be between 1 to 400. So, we have discrete variables. We do not have continuous variables. These type of problems are known as combinatorial problems. In combinatorial problems, a typical problem looks something like this. For example, in our case, we are saying that there are 400 possible sections. So, our n is 400, and we are saying that we are creating a maintenance plan for 10 years. So, T is 10. Now, X11 represents the treatment which will be given for section 1 in year 1. Similarly, X21 represents the treatment which will be given for section 2 in year 1, and so on. We have already discussed that each of these variables can take a value from 1 to 5. That is, we can say that section 1 we will do nothing, for section 2 we will do preventive maintenance, section 3 we will do light rehabilitation, and so on. For section 400 again we will do nothing. This becomes one possible feasible solution. Now, after year 1, same thing has to be done for another years as well. Here, in a given year when we are taking a decision, we are planning for the next 10 years. So, we need to answer that for a given section for the next 10 years, when will the maintenance be done and what type of maintenance will that be. So, I hope the idea is clear that this is a combinatorial problem because there are several combinations possible. Let us try to estimate how many such combinations are possible. Please pause the video and try to determine how many feasible solutions are there for this particular problem. I hope you have tried this on your own, and you have determined that the problem size in this case will be j raised to the power t multiplied by n, where j is the possible treatment options. So, since we have 5 possible treatment options and t is the total planning horizon, which is 10, and n is the number of sections, which is 400, we see that the possible number of solutions or all the feasible solutions are around 5 raised to the power 10 multiplied by 4000, which is a huge number. It comes approximately around 1.97 multiplied by 10 raised to the power 2795. So, this is a fairly complex problem where the set of solution space is a huge number. So, any optimization technique which tries to determine f of x for each and every alternative and finally finds the maximum f of x is practically and computationally not possible in the current times. This is why for such a problem we often have to rely on heuristic problems. That is why for such problems we have to rely on heuristic based optimization methods. In the research, it is found that heuristic evolutionary algorithms like genetic algorithms are found to be suitable to solve such combinatorial problems. As I discussed, in heuristic algorithms, we do not try to find a solution for all the potential feasible space. We start with an educated guess and then we do iterations to find a near optimal solution. Since in case of infrastructure asset management decision making, the solution space is huge, we have to use some of these heuristic algorithms. Once we try to use an optimization technique, finally the optimization technique gives us a solution. The solution looks something like this, where the optimization problem says that for a given section at a given year, this is the treatment type you should do. So, it might say this is equals to 1, this is equals to 2, 1, 2 and 3 and so on. Alternatively, we have already seen that a maintenance schedule like this can be developed, where it says that for every asset, what is the treatment type which is suitable. Here, this table is determined by the optimization method in a manner such that it tries to maximize Rz, which is f of x. In our case, it was maximize the average condition score. So, basically the optimization problem will try to find an optimal solution which maximizes the overall condition score. I hope this short lecture on optimization has provided a little bit of an introduction to how infrastructure decision making can utilize optimization for decision making. Now, to summarize our discussion, we have seen that when it comes to budget programming, there are several methods. Optimization is one of them, AHP is another one, and then we have decision trees, decision metrics and subjective experience. In optimization, there are methods which can be used to find an optimal solution which satisfies our constraints or circumstances. We have seen that for efficient infrastructure asset management decision making, we want a comprehensive decision which includes or provides a solution to all the 3 questions: where, what and when. With that, we end our discussion on week 5, where the focus was on different aspects of decision making. We have discussed economic decision making, multi-criteria decision making and multi-objective optimization. The discussion in week 5 was part of our holistic discussion on a generic infrastructure asset management process. In week 3, 4 and 5, we have discussed different aspects like data collection, performance modeling, development of alternatives and decision making. Within that, we have also discussed about budget, where we talked about needs assessment as well as budget programming. Now, in the next week, we will discuss more around policies and goals. We will discuss what are the different considerations in infrastructure decision making. Right now, we saw that we had an optimization problem where there was a single objective of maximizing the average network condition. But an infrastructure decision making company or an agency might have several other objectives in their mind. So, in week 6, we will get into the details of this and then we will try to summarize how decision making can account for all those objectives. Now, here are some of the important references around this topic. With that, I want to end the discussion in this lecture and the discussion for this week. Thank you. Thanks for listening.